Okay, third example for continuity. Find constants a and b so the function f of x is continuous, where f of x is a piecewise function, so it's x plus 1 when x is less than 2 or equal to 2. It's ax plus b when x is between 2 and 4, and it's x squared when x is greater than or equal to 4. So, what we got to do, let me draw this graph here, a rough sketch, so you kind of see what's going on. So from at 2, so when x is less than 2, we're going to have a line x plus 1, which is going to look something like this. And then at an x value of 4, we're going to have a parabola, and that's going to start at 16. And it's just going to be a curve that keeps going up. So we need to find the constants ax plus b so the function stays continuous. Alright, so at an x value of 2, this x plus 1 takes a y value of 3. And at an x value of 4, this y value is 16 of this piece right here. So, to make it continuous, the y values at each of these edges of the pieces has to be the same. So, y equals ax plus b, this is the second piece, and at an x value of 2, the y value of this second piece has to equal 3. Does that make sense? So we have an equation here, so 3 is equal to 2a plus b. Right? So let me go over that one more time. So at an x value of 2, because this first piece has a y value of 3, if the function is to be continuous, which is what we want in the question, the y value of this at an x value of 2 also has to equal 3. So we just wrote out this second piece as y equals ax plus b, and we plugged in 3 for y and 2 for x, and we have an equation. Okay, so now moving on to the second part of this function. So at an x value of 4, the y value of the third piece is 16. And for this function to be continuous, that means that the second piece has to also have a y value of 16 at an x value of 4. So if we rewrite the second piece like this, y equals ax plus b, at an x value of 4, the y value has to be 16. So we'll have 16 is equal to 4a plus b. Does that make sense? And now notice how we have these two equations with two unknowns, and we can use substitution or elimination to solve. So I'm going to use substitution, so I'm going to isolate for the b by bringing the 4a over. So 16 minus 4a, and then I'm going to sub in this b for this b here, so I can rewrite that here. So let's rewrite the first equation. 3 equals 2a plus b, and then I sub in my b value from the second equation here, so that'll be 16 minus 4a. I bring the 16 over, so I'll have 3 minus 16 equals 2a minus 4a. And then I'll have negative 13 equals negative 2a. And that means a is equal to negative 13 over negative 2, which is just 13 over 2. So our a value is 13 over 2. So taking this value of a, we can plug it back in here and get our value for b. So let's rewrite this equation for b. We'll have 16 minus 4a. So we'll have 16 minus 4 times 13 over 2. And when you work this out, you should get a b value of negative 10. So our a value is 13 over 2, and our b value is negative 10. So our second piece here would be 13 over 2x minus 10. And if that's what the second piece would be, then this function would be continuous. We would just have like a line that joins those two ends.